Thank you, Keith. My name is Roy Arends. I indeed work for the Office of the CTO at ICANN. I want to echo Neil in giving a big shout out to the UKNOF team. We practiced the other day. This is running very, very smoothly as compared to other virtual meetings that I've been part of. So well done. At ICANN, we run a root server. The LRoot server, to be precise. We don't call it LRoot anymore. We call it the ICANN Managed Root Servers. The reason it was called LRoot was because of a configuration long time ago. We prefer to call it IMRS now. It's just to step away from the idea that running a root server or running a letter is something important. So at ICANN, we regularly analyze the IMRS traffic, and of course in recent times with COVID-19, the question was posed to us: have the traffic patterns changed in light of recent events? And we've all seen the different graphs. We just seen one from Neil, how staying at home would impact traffic, but we didn't yet see that specifically on the DNS. So this is an ongoing investigation, but we have some initial findings, which I thought was very, very interesting. I've got a slight warning. I get very enthusiastic talking about research, and sometimes that can be misconstrued as this is a very interesting opportunity to research this traffic. Of course, I'm completely aware of the situation that we're in. So I apologize beforehand if I'm a little bit over enthusiastic. Anyway, so if you squint your eye a little bit, you can see on the right-hand side in this box that you now see on your screen that the traffic has slightly increased. What you here see is query per second for all instances of the ICANN Managed Root Servers, and we run a lot of instances. Instance is basically an anycast instance of a single IPv4 and a single IPv6 address. So this is between January 2020 and the 31st of March. The actual increase is 20 to 25%, and I'll show you that a little bit better later. We didn't look at all traffic. We could, but we didn't, because lockdowns happened on a nationwide scale, not on a global scale. And it happened in different times in different nations. So for this example, for this research, we took a look at France. We have 4 ICANN Managed Root Servers instances in France, 2 in Paris, 1 in Lyon, and 1 in Marseille. And the reason we picked France is because the lockdown there happened in very quick succession. On Friday, March the 12th, the government announced that schools and universities would close by next Monday. Then the day after, on Saturday, it was announced that gatherings of more than 100 people were prohibited. A day later, non-essential public places closed. And on that Monday, it was announced that a national lockdown, a complete lockdown, would start the day after on Tuesday. Now, just because we have a few instances in France, that doesn't mean that all the traffic that we observe there is from France. So how do we know who is talking to us? Well, we used RIPE Atlas probes. The RIPE Atlas probes regularly send a query, identification query, to see to which instance they're talking to which root server instance they're talking to. And the ICANN Managed Root Server reply with a location code, a UN low code. So it would, for instance, be fr-pair to say that's in Paris, France. All the instances that observed, literally all the instances that observed a location code from France, so that saw the instances in France, are plotted here on a map. And you can see that the bulk of them is in Europe and a large part is in France. And we thought that that volume was big enough to notice if there is a change in traffic. So if we look at traffic to these 4 instances over the last couple of weeks, you see here queries per day, which is a little bit more clear than if you look at queries per second. After the black stripe, you see the increase after the lockdown on the 17th of March. So the black stripe is midnight 16 to 17 of March. This is the orange part is traffic for names that do not exist. So that have a top level domain that is not delegated from the root zone. The blue part is traffic for domains that do exist. Now this is accumulated. It's not one on top of the other. It's blue is really a lot less. So there's a lot less traffic for things that do exist than for things that don't exist. How did we do the comparison? You can't just take another root server and compare it to that, or an arbitrary week and compare it to that. So we took the 6 weeks preceding week 12. We measured queries per week. We took an average of that, and we then took the week that was closest to that average. So the lockdown started in week 12, and we looked at week 6 to week 11, took the average of that. That was 5.4 billion queries per week. And the closest one to that was week 6. So we compared week 6, long before the lockdown, to week 12, which is the start of the lockdown. I hope that makes sense. What did we look at actually? It doesn't make sense to look at each individual query, so we classified them. We classified them in the following categories. We have queries for domains that exist. We have, for instance, com, UK, net, etc. And the rest of the categories are for domains that do not exist, and they are categorized as follows. We have domain names that don't exist, that are between 7 and 15 characters long. They receive a special category in the Chromium category, and I will explain to that later what it actually means. Then we have jumbo labels, jumbo queries for domain names and non-existent top-level domains, of which top-level domains are 15 characters or longer. Then we have queries for .home, .lan, .local, and .corp. And then we have queries for all the other top-level domains. So I have here a highly confusing table. Sorry about that. How do I go back? That's how I go back. What you can see here is the week 6 and week 12 in the two tables next to each other. What you see below are the totals. So the individual percentages that you see on each line are a fraction of traffic observed during that week. So if you see, for instance, 30.6 for Chromium queries, that's 30.6% of all traffic that week. And so now you can compare an increase and a decrease in traffic for those categories. Chromium queries went up with 41%, and jumbo queries went down with 64%. Etc., etc. I have that in the table, so you can actually classify this. So I actually view this a little bit better. We compare here week 6, blue, before the lockdown, with orange, after the lockdown, in the different categories. And you can see that, and the percentages that you see here is a fraction of the overall traffic. So queries for domain names that exist, in percentage actually went down. But if I go back a table, you see that there is an increase in absolute traffic. So there's a difference in explaining this. So overall traffic went up, but as a fraction of total, the things for domains that exist went down. Chrome went up slightly, jumbo queries went down, home went up massively, corp went up massively, local went up massively. I use the term massively to exemplify that it's an order larger than before the lockdown. And all the others went down massively as well. Let me go to the next slide. So I'm going to highlight now these 3 categories in blue for home, corp, and local. And we have a theory why, a bit of conjecture, a hypothesis, if you will, what the causes of increase of those 3 things. So when you normally work in a corporation, you may have you may make use of a domain that's locally configured, for instance, .corp. .corp is not delegated from the root zone, but you may have locally configured this. Microsoft advised on this a couple of years ago. Your organization's resolver has a way to understand this kind of traffic. But if you work from home now, and you open your laptop and you start working, you probably make some initial .corp queries, which is, sorry.
Excuse me, Roy, that's 10 minutes. That's okay. 10 minutes.
Okay, I'll be really quick. So anyway, for home, corp, and local, the queries went up massively. We think this is due to people working more from home than at work. I'll skip this one, and I'll quickly go over the Chromium. The reason why we put Chromium in a separate set is because the Google Chrome browser at startup sent a nonce basically to see if it's behind a kept portal. And you see here the top level domain lengths, and between 7 and 15 characters long, you see that it's so much traffic that it pushes down all the other traffic together. So we see millions and millions of queries that are basically random characters. Overall, basically looking at several instances, between 30 and 50% of all traffic to the root server, not just ICANN's root server, but all the other root servers as well, between 30 and 50% of traffic is because Google sends a nonce, the Google browser sends a nonce. And if you know that the function, when you start calculating the cost of deploying a root server, it's always going to be a function of the traffic that you observe. You need to provision several times for the traffic you observe in order to deal with peaks. So this traffic is maybe helpful to the Google browsers. It's not helpful for root zone traffic. Anyway, we continue this research. We hope to give you an update, maybe the next UKNOF, but we're going to publish a paper on this as well. Anyway, thank you for listening, and thank you for allowing me to present here, Keith. Any questions? Let me hear that.
Thank you, Roy. Yes, we have one question for Roy. Go ahead.
We have a question from James Blessing. The question is, did you see a change in queries from providers of OpenDNS or DOH resolvers?
No. The reason for that is, if you want to look at changing queries from specific providers, you need to know the exact set of addresses that they are, the OpenDNS resolvers that they are. Now we know the address of OpenDNS resolvers, but it's a little bit more specific, more to the point kind of research. So no, we didn't do that. It's an interesting question. For the rest, there are so many DOH implementation, or there are various different DOH implementations that we don't know which DOH client actually talks over normal DNS to a root server. What I mean with DOH client is a resolver that like Google, for instance, and like Cloudflare's open resolver that allow for incoming DOH, but actually query the root server over a regular DNS. So we don't know who actually are DOH enabled. Hopefully that helps.
Do we have any other questions for Roy? Yes.
We have a question from Greg Cools. If we could, should we block Chromium queries?
No, absolutely not. No, we should not block, even if we could, we should not block Chromium queries. We should not, as a root server organization, root server operator, we should not block any queries at all. There's two reasons for that. One is that's basically too political. What should we query? It's a slippery slope when you go that way. What's next? What should we stop querying next? The other thing is when you look at the actual working of a name server, sometimes it's better just to respond than actually have to go to a blacklist first and see to whom you can respond or not. So it's I would say no. I think a better approach is to talk to actually, and we have, to talk to Google Chrome to see if we can improve on their captive portal detection and see what comes out of that. Thank you. Ah, okay. I see your question. Caveat: I work for an ISP who has to process all of these recursive queries. I can imagine. Yes. I work at a root server operator who has to process all these queries too. So.
Okay, and we have one more. We have one more question.
It's from Beno Overinder. The question is, can you look into seasonal changes and trends, like economic figures are compared to the same period of 1 year ago?
Theoretically, thank you for your question, Benno. Theoretically, yes, we can, but there is so much traffic, and so much of the traffic comes from automated instruments, bots and whatnot, that you need to understand what the traffic is first before you can classify it into specific categories and then compare it to economic trends. So we did our best here with classifying it in different categories, but we need a much higher granular categorization for root server traffic in order to do that. Happy to do that though, it's very, very interesting.
I don't think there's any more questions.
Okay, thank you, Roy.